Hello, everybody. Thank you so much for joining us today. My name is Grace, and I'm a data science engineer here at MathWorks. And today I'm joined by Valerie. Valerie, would you like to introduce yourself?
Sure. Hi, everyone. It's great to have you here. I'm Valerie Elliott. I'm a member of the WIDS Worldwide Global Team, and I run our WIDS Datathon program.
Awesome. Thank you for joining me today. Valerie and I are here to tell you about creating machine learning models. We're going to use a real oncology patient data set to take you step by step through the process of cleaning and processing your data and creating machine learning models. This data is provided as part of this year's second WIDS Worldwide Datathon. Valerie is part of WIDS Worldwide. So you may be asking yourself, what is WIDS Worldwide, or Women in Data Science Worldwide, as you see here? And we've got a little video we'd like to show you to introduce them to you.
I hope you enjoyed that video about WIDS. I'll give you just a brief overview of the program. So Women in Data Science, known as WIDS Worldwide, was developed as a worldwide initiative back in 2015. We originated from Stanford University, and now we are established as our own nonprofit. And our mission is to get 30% women in data science by 2030. And so we have developed a suite of programs that are ultimately designed to elevate, educate, and inspire women in data science. We also work with a global WIDS ambassador community to help elevate women in their own regions in data science. And so we've just been really honored to work with MathWorks, who has been one of our ambassadors for a long time now. And they will be, of course, here with Grace. We'll be talking about specifically the WIDS Datathon. And so for the WIDS Datathon, this is one of our initiatives amongst our suite of programs designed to educate women in data science. And so every year we launch a global predictive analytics challenge that is ultimately designed to help you hone your data science skill sets while solving a critical social impact challenge. Every year we work with a dataset collaborator to provide a real world data set focused on social challenges. And in a minute, I'll go into our data set for this year. We invite everyone, all data scientists all over the world, to participate in our datathons. And so if you're watching today and you are a beginner or an intermediate or an expert in data science, we invite you to participate in our challenge. I will also note that every year we do have the majority of participants are first timers. And so if this is your first competition, or if you've never done a datathon or a hackathon before, I encourage you to check it out. And I hope that you'll find our tutorial today that Grace will lead, working on the datathon through MATLAB, to be very helpful to get you started. Ultimately, our WIDS Datathons are designed to help you enter the field of data science. And so, like I said, it's really approachable for beginners, and we hope that you'll find the challenge to be really fun. I'll go to the next slide. So to dive in a little bit more on this year's challenges and our challenge topic, we are looking at equity in healthcare this year. We've partnered with Gilead Sciences, who are the sponsors of this year's Datathons, and they've provided us with a very real-world, unique data set focused on patient data that contains a ton of demographic level information, all focused on women who have been diagnosed with breast cancer. And so ultimately, we're looking at an oncology data set. For this specific April challenge, we've actually enriched the data set with some climate level data to give you a deeper sense of and help you look at and analyze how climate patterns impact access to patient care. And so this will give you a really good view into equitable access to healthcare. This challenge task that we just launched last week, it is a regression challenge. And the problem statement that we're looking at is to develop a model to predict the duration of time it takes for patients to receive metastatic cancer diagnosis. This is one of the most aggressive types of cancer, and so it'll be really important to look at this topic. The data sets are located in Kaggle, where the competition takes place, and you'll find both training and test data sets to work with to solving this year's challenge. As I said, the challenge is currently open. It opened last week and it runs through June. And so there's plenty of time to get started. And we'll drop a link at some point during this hour in the chat where you can sign up to participate. And so I'm going to hand it over to Grace, who's going to show you how to get started on the Datathon using MATLAB.
Awesome. Thanks, Valerie. So now we have a basic understanding of the problem that we're tackling. We're going to develop a model to predict the duration of time it takes for patients to receive their cancer diagnosis. So I'm going to dive into MATLAB, but if you guys have any questions at any point throughout this live stream, feel free to put them in the chat and we'll be responding to them as we can. So let's get started. All right, so this is MATLAB. Hoping some of you have used MATLAB, but if you haven't, I'm using what is called a live script, which just lets me run code in small chunks. So all of the code that I'm showing today is available for you to download on our Student Lounge blog. Again, it will be linked in the chat, and it is linked in the description of this YouTube video. So you can totally go there and download this. I'm going to start with importing our data, because what's a data science challenge without any data? So first, I've gone to Kaggle already. I've downloaded this train.csv from Kaggle, and I'm going to use the read table function here to read the entire spreadsheet in as one table. And we're going to see a preview of that data here. And you know, in MATLAB you can scroll, so I'll scroll around. And it's a pretty big data set. We can see up here it's 13,000 rows and 152 columns. Valerie, do you know around what size this file is?
It's at least a few gigabytes. And so it's a large file, but it's not too large to close your computer down. And so we make sure to make it digestible enough for your software.
Absolutely. So right, I can load it all in as one table, but trying to draw meaningful conclusions from it by just scrolling around is a little difficult. So I'm going to use this summary function, and I'm hitting the run section button up here, if you can't see that. And what summary does is it prints out some high-level information about all of the columns or variables in this data set. So patient ID is numbers, and some things that I'm noticing as I'm scrolling through here is we have a couple of these cell array of character vectors, which doesn't give us any information really. We've got some doubles, but the doubles have different minimums and maximums. You know, this one's 1891, but this one's 100 and 995. And we're also seeing that some of them have this num missing property. And so this is BMI, common statistic, but it's missing over 9,000 entries in a 13,000 row data set. So basically, I've written these observations down here, but we're going to use these observations to make some decisions about how we want to clean and pre-process our data set. So first, number one, there are a lot of rows or variables that just say cell array of character vectors. So I'm going to convert those cell arrays of character vectors, to categoricals. And what that does is, let's say patient state. If you live in Alabama, that's AL. If you leave that as is, as a character vector, the machine learning model might look at that and say AL, interpret it as just a collection of characters. But when you turn it into a categorical, it realizes that all of the people that have AL are in the same category for that variable. So they're all from the same state. And so that makes it easier for the machine learning model to pick up some patterns later. So the way I do this is I look at every row in the table, check if it's a cell array, and if it is, I convert it to a categorical. Perfect. Number 2 is that missing data that we talked about, and we're going to go through this and remove missing data in 2 different ways. So first, I'm going to go column by column, as we saw in the summary function, and I'm going to remove any columns that are missing over half of their entries. So this for loop right here just goes through and checks how many num missing, how much num missing each column has. And if it's missing over half, display the name right here. So we've got 4. So I'll remove those 4 from our data set entirely. And we can see that the updated one is displayed here. It has 148 columns instead of the 152 that we saw earlier. The other way that I'm going to clean data is actually go row by row, because we've removed some big chunks of missing data, but we still have scattered missing data throughout our table. So I'm going to go row by row and say if you're missing 2 or more entries in this row, we'll just take it out. Because we have a pretty big data set, there's a lot of different ways to handle missing data. So we could try to fill it in, we could just leave it and hope it's fine. But since we have a pretty big data set and this is a pretty straightforward tutorial, I'm just going to use this clean missing data live task. So I don't have to write any code, I get to write buttons, or I get to press buttons to remove any missing rows, any rows that are missing 2 or more. And all of these X's here are individual rows that were removed. You can explore the data a little bit more with this drop down here. So we can see that none of the rows were missing patient ID, because that's a pretty important part of the machine learning part of the data set. But if we go to patient state, for example, I'm going to take a second to re-visualize everything. And it would normally show, there we go. So it'll break it down by state, so which data was removed. So if you want to make sure that you're not removing whole chunks of data, this is a good way to explore that and make some informed decisions. Great. So that's number 1, the cell arrays. Number 2 is missing data. Number 3 was different minimums and maximums, but I'm actually going to take care of that afterwards, because that's when we start manipulating the data, and I want to take some time to just explore it first. So again, when it comes to exploring data, there's so many things that you can do. I'll show some simple ways to get your brain started thinking in the right headspace, but I'll break it down into a couple different categories. So first is univariate analysis, or single variable. And I'm going to run that, and I'll explain it as we go. But I'm working with the patient age variable shown here. You can do this with pretty much any numeric variable in this data set, but I'm going to use the KDE function to get the kernel distribution estimation, which is just kind of a fun way of saying it's a smoothed out representation of how our data is just distributed. If you're familiar with histograms, it's kind of similar to that, but instead of bins, you're getting this plot. But it also makes it a little easier to ignore outliers and get a better sense of how your data is distributed. So we can see we peak around this 60 years mark. We've got another peak right after 80. So you can try this out with a bunch of different variables and see what kind of population you're working with, and if there are any gaps in your data and stuff like that. Now that was univariate data. This is bivariate analysis, which is 2 variables, or this could also be considered multivariate analysis, which is just analyzing 2 or more variables at a time. I'm going to use this fun create plot live task. If you're wondering, there's a task button up here that you can just click on. And I know this is a little hard to read for the live stream, but I'm not going to go into it now. But there's just a bunch of tasks that you can do without having to write any code. So I like to use those when I can because they're pretty flexible. So this is the create plot live task. I've passed it our data set that I've cleaned up. And you can use this to compare 2 variables. I like to start by comparing one of our variables to the expected output. So the metastatic diagnosis period against a bunch of the variables. So right now, let's just pick patient state. And that's going to take a second, go through the data and replot everything. Awesome. So we can see here that it's the patient state plotted against the diagnosis period. I'm at first glance, I'm not seeing anything too mind-blowing, but you'll notice that I started with the diagnosis code. And so when I was going through the data, I kind of noticed that there were some differences. These first codes all the way up, all of these first several that start with a C, it looks like, tend to skew to the left or maybe center, kind of indicating that maybe they tend to get earlier diagnoses. But some of these other codes down here might skew a little bit more to the right, maybe indicating that some codes tend to take longer to diagnose. Again, just the beginning of doing some data exploration. But play around with these. You can look at any variables you want. A good way to understand your data and make some informed decisions about what you want to do with it. Now, those are both graphical analysis. It's important to also do statistical analysis. So again, super simple example. I'm going to say that I want to know what the average age of the population is in our data set, kind of like what we plotted earlier. So I'll calculate the mean age here. And then I'm going to add a variable to our data set. You'll see now it has 149. That is the patient's distance from that average age. So their age minus the average age. And I'll add that all the way to the end. Sometimes the preview, there we go, years from mean age. So if it's negative, you might be younger. So just a super simple way to augment and learn a little bit more about it. So maybe this will be helpful, maybe it won't. Great. And that's a great transition into feature engineering, actually. So feature engineering is kind of any steps that you take to manipulate your data or augment it. So with the statistical analysis example, we added a new variable. But anything that you do to try and maybe you get rid of some variables, maybe you create new ones from the existing data, or you adjust the ranges. Changing your data from the state that it's in to a state that you think will help the machine learning model learn better is an important step of machine learning. And I'm actually going to have MATLAB do this step for me. So this takes a little bit of time. So I've done this ahead of time, but MATLAB has this GenR feature functions, which is generate features for a regression problem. And I pass it the data set, I pass it the output, so the diagnosis period, and I tell it how many features I want. So I chose 30. And the reason this takes a while is because it goes through the data set and kind of tries different things to see which variables are going to have the strongest relationship to that output. And it'll try and create new variables that'll have stronger correlations to the output so that all the variables are helping our machine learning model make informed decisions. So this is the output of what that would look like. It'll tell you a high level of all of the variables that it's created, the features. I'm just going to load it. Oh, my bad. I'm going to load it into workspace. And now we have this T and this augmented train data. And so aug train data is the data set that we've created, taken our existing one, manipulated it. But T is a transformer, which will allow us, if we get extra data, like our testing data set, for example, or if we just happen to get new patient data that has all of the same rows or columns as our original set, we can use this T, this transformer, to manipulate the new data into the same format so that we can use it with our machine learning model. This describe function makes it a lot easier to understand what's going on. So it tells you things like the data type. So we've got a couple categoricals and some numerics. Is original tells you if it kept it in the same format as it was. So we can see it kept the diagnosis code and description the same. And pretty much everything else, it's done some kind of manipulation on, especially with the numeric one, you'll see a lot of this ZSC, which is a Z-score. It's a standardization, and that basically takes care of problem number 3 that we noticed earlier, which is that the columns had different minimums and maximums. So our data has been processed, it has been cleaned, we've got some features that I think are pretty interesting. Now it's time to train a machine learning model. Okay, so I'm going to run this, and then I'll start describing it. So I'm going to use this fit R auto function that you're seeing here. And that's going to automatically fit a regression model for us. I'm going to use ASHA optimization. There's a couple different kinds. You don't need to know the details, but in case you're curious, ASHA handles large data sets better, and this is a pretty large tabular data set. I'm going to use holdout validation, which essentially will take 20% of the data out of the data set, and it'll use it to calculate the loss that we're seeing right here. So this is that 20%. So it'll train a machine learning model and then calculate how well it performs on that 20% that we've held out. And for the purpose of this demonstration, I'm just going to have it test out 20 different models. But when you run it without any limitations, I think it runs about 340. But you'll see as it's iterating, it'll print out how many models it's trained, what kind of model it is, the different hyperparameters it's trying out, and how well it performs. And it'll also plot this optimization progress box for us. All right, I'm going to let that run for a second. Do we have any questions? All right, well, I will keep going, but keep those questions coming if you have any. I promise we're friendly. Okay, so it's on 18 right now. I'll give it another second, but I did also save one that was trained on the 340 different iterations, so I can load that one. But I just wanted to give you a sense that it tries out a bunch of different types of learners and makes it super easy. Another fun way to train machine learning models is through the regression learner or classification learner apps, depending on what kind of model you are trying to train. So I'm going to go to this apps tab up here. I'm not going to show you all of it. We have lots of videos on it if you're curious, but just want to make sure that you all know about it. And we have these classification learner and regression learner apps. And those essentially just let you interactively create and test out and prototype different machine learning algorithms. And so it's a separate app that comes as part of the statistics and machine learning toolbox with MATLAB. And it lets you open a new session. I would be from workspace. And it'll ask you, which variable is your predictor? Do you want to use all of your all of your variables, what kind of validation you want to do, super customizable. I'm not going to do it now. And then you can just click on what kind of models you want to train them right in the app. And when you're done, you can export it to the workspace. So if you aren't sure what kind of model you want to train, wanted to try something out interactively, I recommend you check that out. It's fun. Awesome. So I'm going to load the model that I trained. And so once you've played around with it, you've got a machine learning model that you are proud of or that you just want to give it a go, you can start making predictions on your test data or on new data. So again, from Kaggle, there's a test data set that I'm going to load into the workspace. You see this warning, that doesn't mean anything's going wrong. It just means MATLAB has a specific way it likes to format its variables, so it might modify the names a little bit to make sure it matches. But that warning is totally normal. And then you have to pre-process your testing data the same way that you pre-processed your training data, because that's the format that your machine learning model is expecting the data to be in. So we took a bunch of steps at the beginning and used some apps, but I've just written some code that does the same thing. So I'll run this right now. But this converts those cell arrays to categoricals. It removes the missing data that we were worried about. It adds the years from mean age variable that I created, and it transforms our data set into the features that we generated earlier. And then you can make predictions. And in this case, if you do choose to participate in the WIDS Datathon, you can submit your predictions to Kaggle. So for Kaggle, you make your predictions and then you turn it into a table. So we have the patient ID so that we know who we're making predictions for. Like I said, it's pretty important. And our predicted diagnosis period. And then I've exported it to a CSV file that if you're looking closely, you can see it's right here. And that's it. That's a start to finish workflow on machine learning, from getting your data set to making predictions. Do we have any questions? Or Valerie, is there anything you want to add?
Yeah, so Grace, you know, this data set's so large, right? And there's so many ways that participants can look to understand the data or create their models. How are you deciding which variables you want to try out in your models?
Yeah, I mean, honestly, so here, I'll go back. Part of it was just by starting with this, there we go. Okay, the bivariate analysis was, I found very interesting, trying to look at what relationships certain variables have to the output. Seeing if you can find any kind of patterns in there is always a great start if you're trying to do it on your own. Part of what I like about the GenR features function is that you don't have to do all of it on your own. You know, it did some fun calculations that I probably wouldn't have thought of on my own. But thinking about, okay, and even just taking a step back from looking at the data, but looking at the headers and being like, okay, well, do I think this would impact that? And some of that might depend on your knowledge of cancer diagnosis or healthcare. But there's so many different approaches that you can take to it. Great question.
Yeah, there's really no one way to solve the challenge. And, you know, like Grace is saying, based on how you want to look at the data and how you might want to understand it, you can use any kind of information to figure out how you might want to test different variables.
Absolutely. Did I miss anything, Valerie? Do you have any recommendations for participants?
You know, this looks really good. I always encourage participants to see, it's fun to see what kinds of correlations can you get, what kinds of patterns can you deduce from the data. But I think this is a really great start. And like I said, there's so many participants who have never done a challenge before. And I hope that you'll find this really helpful to see how you could start.
Yeah. And if you are participating in the Datathon, there's a fun discussions thread, I guess, a little discussion section where people, again, beginners and advanced alike, are just having conversations about things they notice in the data set or problems they're encountering when they're trying to make their own models. So it really is a community event as well. Awesome. Okay, well, I think we're about ready to sign off, but definitely check out the Datathon, put these new skills to the test. In the link, the blog link that has this tutorial, if you do not have MATLAB, we are providing complimentary licenses just for this competition. So you can find a link to that there. And if you do end up having questions after we sign off, feel free to put them in the comment section. Anything else to add, Valerie?
Wonderful. I just want to encourage everyone to participate. As Grace said, it is really a community event. We have a Datathon Slack channel where you can also communicate with participants all over the world and form teams together. We really do encourage you to group up to work on the challenge. It's more fun to collaborate together in groups. And so feel free to sign up, form a team, work on the challenge. We also have Grace's tutorial linked directly on the Kaggle page, so it's really easy for you to access it and find this code. And so we hope that you participate and enjoy it.
Yeah.
And thank you, Grace, for sharing all of your knowledge on MATLAB. This is really insightful.
Happy to. Thank you, Valerie, for joining us today. All right. Thanks, everybody.